Hey guys, welcome to another welding video. Today we're going to be going over a couple things that I forgot to mention during a previous gas welding video, doing Oxy-Acetylene. I'm going to talk a little bit more in depth about the safety, change a couple things that I talked about last time as I've read a little bit more, and I think I've developed some bad habits over the years. I'm going to talk a little bit about the actual components inside your torch handle and a couple little tips here for that. So one of the first things that you want to check before you start welding, are your tanks secure? If you're using a mobile cart, are they going to fall over? Is this tank good enough? Is it going to hold it in place? When this thing's not moving, these aren't going anywhere, and it's enough to keep them in place. If they're attached to a wall, make sure they're attached securely with a chain. And then the next thing you want to do is double check that all the connections are tight. Now, these ones should have been tightened with a wrench. These should have been tightened with a wrench. These should have been tightened with a wrench, etc., etc. These ones here. These ones also have a built-in flashback arrestor. That's going to prevent gas from going the wrong direction, going back through here. You don't want to have oxygen go into the acetylene or acetylene go into the oxygen valve here or through that hose. So that's going to help with that. We've got one here, one here, one here, and here, so we are pretty much covered. Next thing we're going to want to double check is making sure that this has only been hand tightened. So there's different tips you can stick on to the end of one of these, and this should have only been tightened by hand. On the inside, there should be two O-rings. I've got one here and one here. Let's take a closer look at that. So I've got two O-rings. See if you can see that here. There's a small one here and a small one here. You want to double check that those are still in good condition. If one of those is to fail, there's a chance of gas escaping and going the wrong way. These ones are still good. It's a little bit dirty around here, but that's just, again, carbon. The actual O-rings themselves, they still feel rubbery, so that's good. What you don't want is for them to be hard and brittle, because then they are essentially useless and unable to create a good seal. I'm going to reattach that to here. I'm using a number 0 tip for this. This is kind of the most common one I use in the shop. We are rarely welding anything above 1/8" mild steel. Aim it the direction you like. Make sure it's tight for how you want to hold it. I like to hold it with this with my valves up here. Just easier access when I'm welding instead of being flipped upside down. Just hand tighten. If you use a wrench and you try to tighten this here, you risk damaging the O-rings that are under here. If you over tighten it, you're going to squish them, warp them, and that is going to cause something bad to happen. So that's tight, good enough, good seal. These ones, I've had it happen before where one of these was not tight enough, and I actually had flames shoot out here around the hose, close to where your hands are. It's very important to make sure that these have been tightened correctly. If you're able to loosen these by hand, something is wrong. Let's take a closer look at the tanks now. So you notice here, nothing's been set up yet. Both dials are down at 0, both my tank pressure and the actual gas pressure that's going to be coming through the hose. Before you do your setup, ensure that there's no pressure in this system at all. You don't want this basically hammering this with a big pressure. If you've ever been in an older home and the plumbing, sometimes you hear a knocking sound in the wall as you're turning, your hot water on or something. It's basically hammering into here, and that can damage the diaphragm and the other parts inside your regulator. So you want to make sure that that's been opened, all your pressure's been backed off, these are at 0. Perfect. Double check the same thing for your oxygen. On the oxygen here, I can also verify that these are both at 0, 0, nothing left in there. I can't feel anything. My regulator has been backed off, and now that means that this is safe to open. So let's go through the procedure of actually setting up the tanks correctly now. So now that I have verified that everything's down at 0 and this is safe to use, I'm ready to get started here. So I'm going to start with acetylene before oxygen. This is just the habit that I've developed. It doesn't really matter which tank you set up first, as long as your lines have been clear, they've been purged ahead of time. You don't want to have excess amounts of carbon or oxygen floating around inside your torch. So this is the way that I'm going to do it. The rhyme that helps me remember this and helps students remember kind of the order of operations is A before O or up you go. So acetylene before oxygen or up you go. If you do some of these things wrong, you run the risk of small explosions or popping noises and all sorts of things coming up. I've been doing this for about 15 years and I've never had anything dangerous happen, but I have developed some bad habits and I'm going to try to rectify those with this video. So step one, we're going to open the valve to our cylinder here. This is the acetylene cylinder. We're going to open it half a turn. So if my line starts here, I want it to get to here. I'm going to open that half a turn. The manufacturer recommends between half a turn, 1.5 turns, but I like to do half because it's really quick and easy to turn it off quickly in the case of an accident. So after you've done this, step one, open your valve. Step two, on your torch handle, open your acetylene or fuel valve, maybe about a half turn. After this has been opened, I'm going to adjust this. I'm going to turn it in the plus direction because I want to increase pressure. For me, we run it usually between 6 and 7. So I'm going to turn that handle and watch closely on this valve right here. And there we have 6. I can hear the acetylene coming out. I'll hold it up to the microphone so you can maybe hear it. Good. I'm going to go ahead and turn that off. So that was 4 steps. Number 1, open the acetylene valve on the cylinder half a turn. Step 2, open the acetylene valve on the torch handle about half a turn. Step 3, adjust your regulator to the desired pressure. This is based on the type of material you are welding or what your manufacturer has recommended. Step 4, turn off the torch valve on here. All right, let's move on to oxygen now. This one we're going to open the valve all the way. Again, I've double checked that these pressures are all down at 0. All the way open. And you can see my tank is running a little bit low, but there's still enough in here to do some welding. Step 2, open the valve on the torch handle for oxygen. And if you're not sure which is which, sometimes it's labeled, but usually just follow the hose. I've got a green hose here and a green hose coming out of my regulator. Open that up about a half turn. Increase the pressure on your regulator. We're going to go to about 10 psi. There we go. I'm at about 10. Turn off right here. So those 4 steps again. Number 1, open the tank here all the way until it stops. If you need a wrench to keep opening it, you're probably going to blow the thing up. Go until it stops with your hand, not breaking off the handle here. So step 1, open that all the way. Step 2, open your oxygen valve on your torch handle, about a half a turn. Step 3, adjust the pressure on your regulator to about 10 or whatever your manufacturer recommends. And step 4, close the torch handle for the oxygen. So now that you know how to set up the tank, it's time to start playing with some fire. Now, before I can actually do this, I need to make sure that I have all of my safety equipment. Recommended, wear a leather jacket. Why do you want to wear a leather jacket? Probably to protect your body from fire or flames or heat. I'm wearing my blue one here, but my students are usually wearing these ones. You probably want to make sure that you have some leather gloves. These are leather welding gloves. Inspect them, make sure they're not covered in oil or grease or anything flammable. You want to inspect and make sure they don't have any holes in them. Do these have any holes? Well, only one big one, so that one's okay. You're also going to want to protect your eyes. Staring at this with, just your bare eyes or a pair of clear safety glasses is not going to do it. I'm using a number 5 shade on my personal ones. We also have these ones, again, a number 5 shade. Or there's a full face mask that you could wear, again, a number 5 shade. So I've set up a little area here to do some practice welding. I'm using some fire brick. I probably don't want to use the sheet metal table that I've got here because the whole surface is going to heat up and warp. Again, use what you have, but be safe when you're doing this. I'm going to be using some mild steel here, and I'm going to do a little filler rod demo as part of this. Just a quick one, and then I'm going to show the shutdown procedures for the tank as well. Got my safety stuff. Again, my area has no grease in it. There's nothing that's able to catch fire accidentally. And let's go for it. So I have my torch. I have my glove ready. I typically don't put on my right glove until the flame is on because it's just easier for me to manipulate my striker. This is the only thing you should be using when you are lighting your torch. You should be using a proper striker. Don't use a lighter. Don't use matches. So I've seen people use a cigarette to do this, but maybe let's just, for the sake of this video, stick to a regular striker. Let's see if we can show that a little bit better. Hard to hold it on this angle. Not a great striker. There we go, we got some sparks. Okay, I'm gonna open up the fuel valve on here just a little bit. So we're gonna do A before O. Open that just a little, as the French would say, un peu. So just a tiny bit, just to allow enough acetylene to come out. Hold my torch away from people, objects, small dogs, things like that. And I'm gonna hold my striker on a slight angle, usually a 45-degree angle. If I hold it like this, where it's aimed straight into the cup, the flame can basically bounce back at me. So I'm gonna hold this on a little bit of an angle, 45 usually. And I can get a small birthday candle style flame. Put my other glove on now, just easier for me to do it this way. I'm gonna open up the fuel valve on here to my desired flame amount. As you can see, all this sooty black stuff coming off, that's carbon. I'm gonna increase this, the pressure slowly and controlled. Now look at that flame. Something looks kind of funny there, doesn't it? It's splitting off in all sorts of different directions, making a bit of a hissing noise. Let's turn this off quickly and realize, why is this happening? So, my first guess is that the reason the flame was splitting into two places is because the tip is dirty. Now, if I look at it just visually, it's very sooty. I can't really see much. So it's a good idea to have a tip cleaner handy at all times when you're working so that you can fix those mistakes. You're going to pick the size of the tip cleaner based on the size of the hole here. So let's double check and pick the right one. I usually start with the small one and work my way up until it's kind of tight. Take your tip cleaner, stick it in the end. It's basically like a tiny file. It's going to help get rid of any little sooty spots or things that can be blocking here. All right, let's try that one out now. Let's light it up and see if it makes a difference. If this problem persists and it's not this that's causing that hissy noise, it could be something else that's wrong here. So I'm going to put my glove back on. Open my acetylene just a little bit. Again, I only want it to be like a small birthday candle. That was a very small one. Adjust it until the black smoke goes away. That is much better. So I've got a little bit of black smoke, but that's okay depending on the style of welding I'm doing. Make sure it's pointed usually close down to your workpiece. Now you see how it makes that all black. That's because it's still that sooty carbon. As soon as I add oxygen, it's going to be a much nicer flame. So I'm going to add oxygen very slowly, using that handle here. Oh, I just got a little bit on the table, my bad. Open this up. So we have a nice neutral flame. Now if you look closely at it, again, it seems to be splitting off into two places. That tells me I still need to clean the tip. So let's turn this off. This is the only time that you're actually going to do oxygen before acetylene. When you're actually turning off the torch, turn off your oxygen first to clear out any oxygen that's left in the system, and then turn off your acetylene. Now it made a mess of my table, but that's all right. I'm going to allow this to cool down before I start working on it. So just let's fast forward until then. So now it's cooled down. Let's clean that a little bit more. It's much easier to do this when the thing is cold so that your hands don't get burnt trying to do it. Get my gloves on and let's go for this again. Open your acetylene slowly. Hold that on a 45-degree angle. Open until that black sooty smoke goes away. Make sure it's pointed in a safe direction away from people. Add your oxygen slowly. We're going to get a nice neutral flame coming out. Now, there we go. So I've got a nice tiny little white tip there. That's a nice neutral flame. It looks pretty good. I'm going to be setting this up based on the thickness of my filler rod. So that's just under 1/8 of an inch. I'm going to say probably about a 3/32. And I'm going to tack it in two places and quickly do a little filler rod weld there. Let's get this lit again. I'm going to start with a quick tack weld between the two pieces to prevent it from warping while I'm working. Let's get them both hot before I lay this thing on there. This first tack weld is not meant for strength, it's just to hold it in place. Another one over here. Once it gets a little bit cherry red, I'm going to just lay that across like a bridge, melt that onto the two. There we go. Double check that that one is on there. All right, there we go. All right, I'm going to get a puddle started and start doing some filler rod welding here. The reason that I have this gap, this is going to allow me to get some more penetration since I don't have the edges beveled or anything. Let's get that puddle started. I'm going to stay in that one space to make sure that it penetrates fully. There we go. Let's start adding some filler rod. Nice and slow movements. I'm holding my torch on about a 45-degree angle, trying to stay even with where I'm going between the two. Dip that filler rod into the puddle as you go. And I'm staying with the puddle until it moves forward by itself. This way I get the maximum amount of penetration I can. A lot of people think gas welding is a real waste of money, but I find this really relaxing and it really helps to teach the techniques, patience, that sometimes MIG welding, where you can just lay a bead in 5 seconds, doesn't show. So I don't want just a surface weld, so I'm staying with it until I visually see that it is filling up that crack by itself instead of just bridging on top. This way I get a lot of penetration, metal's going through all the way to the other side, not just on the surface. This one's not going to be the prettiest weld, but it's going to be strong. Just going to touch up that last part. It's not going to be as strong as the other ones, but I want to get it lined up at the edge. Nice. So when turning off your torch, we used to do A before O. Now I'm going to do it a little bit differently today. We're going to do O before A. The reason for that is I want to make sure there's no oxygen left in this system causing any buildups or any of that stuff. So let's do oxygen first, then turn A off, or acetylene. And this is making sure that the system has been cleared of all gases in there. Let's take a look at this weld after it's cooled down a little bit. All right, to pick up metal, I'm not going to use my hand. I'm going to use a pair of pliers. I don't want to burn myself today. Let's flip it over and take a look at the penetration that I got. So if you look at the metal, you can see that the weld has penetrated decently through. I probably could have had a little bit more over on this side, but overall, that metal did make its way all the way through. That's going to give me a stronger weld. If I wanted to make this even stronger, I could probably just weld it from the other side, but I like to do single-sided welds just to double check, because you won't always have the opportunity. I probably went a little bit wider than I needed to with the bead, but this is again just to demonstrate some of the ways to do it. Let's go smack it with a hammer and see how strong it is. There's the back side. You can see the penetration. Not too bad. Could be a little better. Front side. There's our weld. Little bit messy. I was not being as consistent as I would like. But either way, we get to hit it with a hammer now. Did I say hammer? Yes, this is an 8-pound sledge from Princess Auto. Good deal. We'll see if it lasts more than a year. That's not too bad. That was 2 good hits. Let's hit it from the other side now. So let's see what broke first, the metal or the weld. Looks like it's just the metal that has bent. That is pretty good. So that's much better than the previous video where it showed the metal breaking right away. This one, the weld is still held up. Let's see how close I can get in focus. There we are. The weld is still holding. So by adding a little bit more of a gap in between my metal, using that filler rod and staying nice and slow, it allowed the metal to really penetrate, and that is shown based on the strength of the weld. I gave that 4 or 5 good hits with the sledge, and all it did was bend the metal. The weld is still intact. So now that we're all done welding, we need to make sure there's no gas left in any of these lines, either oxygen or acetylene. At the end of every day, I make sure that this is done. When I have students lined up one after another, we don't make them shut it down every time. But if it's sitting for more than 30 minutes, I make sure that the students at least purge the lines properly and turn the tanks off. That way we're not wasting any gas. The first thing that we want to do is take a look at this. And I'm going to show you the wrong way to do it first. If you just back off your regulator and then open the valve here, yeah, the regulator pressure drops, but look at this. There is still pressure left in between here. So ideally when you do this, that's not the order you want to go. The first thing we want to do is actually turn off the tank, release all pressure in here, and then back off the regulator. So let's set that back up again. We're going to turn off the actual tank first. This way, it's been isolated from anything forward here. We're going to open up the valve to release any pressure. This is the torch valve. Release any pressure that is still in the line. You're going to see both of these drop to 0. So third step, now you back off your regulator. So the order of operations for shutdown is the cylinder tank, or is it the cylinder valve first? Then open up the handle on your torch valve for acetylene. Let all the pressure purge from here, and then back off your regulator. Let's go on to oxygen and do the same thing. First step, we're going to close the valve on the cylinder. We're going to open the valve on the torch handle, again, oxygen. We're going to let all that pressure drop that was in that line. It is wasting some gas, but at the end of the day, I'd rather be safe than sorry. Back off the regulator. Turn off your torch handle. That way, there is no oxygen left in the system. That is all done and shut down. Now, for the longest time, I have always turned off acetylene before oxygen to turn my flame off. The reason that I've done that, and I was taught this way, is in an emergency situation, if you need the flame to go off right away, you turn off the acetylene first and it kills it. So if somebody's on fire, you drop something, you need to quickly reach over, and you can do that. You turn the flame off right away. The correct procedure that you see in most manuals, as recommended by a manufacturer like Victor, is going to be this way. So let me just get it lit here. Make sure those are all off. When it is lit, you've finished all your welding. So let's say you're using the torch, you're welding whatever here. Let's actually put some steel on the table. You've done your welding. You want to turn it off. Normally I do acetylene and then oxygen. Now the problem with that, there's still oxygen running through. You can hear that. I'll hold it up to the microphone. Hear that? We don't want that. We want to make sure there's nothing left in there. So ideally what the manufacturer recommends usually recommends turn off your oxygen first. So I'm going to go oxygen, then acetylene. That helps to purge the line of any excess gas that's in there. Again, personal preference. Usually follow the recommendations of your manufacturer, but in an emergency situation, I think it's okay to turn off acetylene first because it kills the flame right away. One more time. So, emergency situation, your hand is on fire, something bad has happened, hit that acetylene, it shuts off the flame right away. Don't forget to turn off your oxygen. Oh, by the way, don't open both of these and then try to light your flame. That's bad. Just don't do it. Always open only one at a time, which is acetylene first, or whatever your fuel is. There's my nice neutral flame. Manufacturer recommends oxygen and then acetylene. The thing I really don't like about it is when you're aimed at a table, it makes it all dirty. But in the book, that's what it says.